A fast-moving, city bus-sized rock, only about 10 to 15 meters across, is hurtling toward Earth at an unimaginable speed of nearly 14 kilometers per second. That's over 50,000 kilometers per hour. Could this space visitor really do serious damage? Could it tear into our planet like a cosmic bullet? It's not like this is the first space rock to swing by Earth. The universe has been dropping them on us for billions of years. On February 15, 2013, the people of Chelyabinsk woke up to a flash brighter than the sun. And they didn't even know it yet, but a 20-meter asteroid racing toward Earth at 18 kilometers per second had just entered the atmosphere. Some witnesses even reported feeling a wave of heat on their skin as the fireball passed. For a few silent seconds, the world held its breath. And then, boom! A shockwave ripped across the city, shattering thousands of windows, toppling walls, and injuring over 1,000 people. Not from fire, but from glass. If something this small can unleash the power of 500,000 tons of TNT, what happens when a bigger one comes? In today's video, we're going to explore how we could actually deflect an asteroid from hitting Earth, from slamming it with a spacecraft to gently nudging it over years. Because if a space rock is heading our way, every second and every decision counts. Events like this may seem rare, but Earth is constantly visited by space rocks of all sizes. Most are harmless, but some could be catastrophic. The ground-based observatories on Earth have detected nearly 35,000 known near-Earth objects, a mix of asteroids and comets, silently orbiting the sun. Some are no bigger than a car, others larger than a skyscraper, all hurtling through space at tens of thousands of kilometers per hour. On June 29, 2024, the asteroid 2024 MK whizzed past Earth. It's about 150 meters wide, roughly the length of 1.5 American football fields, and came within 295,000 kilometers. That's about 3/4 of the way to the moon. Then, a year earlier, on July 13, 2023, a much smaller object, 2023 NT1, came as close as 1/4 of the distance to the moon. These would have released 200 megaton of TNT and 1.5 megatons of TNT. The space may seem empty, but it's full of hidden surprises. Tiny or fast-moving asteroids, moving silently across the sky at incredible speeds, some no bigger than a bus, can be extremely difficult to spot. Even with our best telescopes, many of these objects are only discovered weeks or months before they make a close approach to Earth. That means for most of their journey, they go completely unnoticed, silently on a potential collision course. Every new detection is a race against time, reminding us that we can't just rely on luck. The stakes of doing nothing are serious. Even a relatively small asteroid, about 100 meters wide, roughly the size of a football stadium, traveling at tens of kilometers per second, could hit with the energy of hundreds of atomic bombs. Such an impact could wipe out an entire city, trigger massive fires, and send shockwaves ripping across the surrounding region. And this isn't just theory. History shows Earth has faced similar strikes. The Tunguska event in 1908, caused by a smaller asteroid about 50 to 60 meters wide, flattened over 2,000 square kilometers of Siberian forest. And the interesting part here is it never actually hit the ground. Instead, it exploded high in the atmosphere, with a blast equivalent to 10 to 15 megatons of TNT. If a similar asteroid hit a populated area today, the consequences would be catastrophic. The harsh truth is that the universe doesn't wait for us to be ready. While we can't just dodge an object that's moving quickly toward Earth, we're not completely without options. Scientists are working on the ways to slightly push these space rocks off the paths that could make them hit Earth. Small changes made years in advance that could turn a dangerous situation into a safe pass. When people imagine stopping an asteroid, the first idea that usually comes to mind is simple: blow it up. Movies has taught us that a big enough explosion can fix almost anything. But in reality, taking out an asteroid isn't as easy as sending a rocket with a giant bomb strapped to its nose. Asteroids aren't smooth metal spheres. Many are loose rubble pile objects, held together by weak gravity, like floating cosmic junk piles. Blow those apart, and you don't always get one problem. You get thousands of smaller ones, each still heading roughly toward the same target, Earth. And that brings us to our first method, the kinetic explosion approach. This is the classic nuke the asteroid idea, using a nuclear device to break it into pieces. Sounds dramatic, and in some cases, it might actually work. A powerful explosion could vaporize part of the asteroid's surface, pushing the rest away from Earth. But the risks are enormous. If the asteroid is weak or fractured, the blast might simply create a shotgun spray of debris, turning one incoming rock into a whole swarm of smaller, still dangerous fragments. It's like turning a single bullet into a cloud of shrapnel. Another approach is the direct collision method, smashing spacecraft or missiles into the asteroid at high speed to break it apart. But again, destruction isn't guaranteed. Many asteroids are shock-absorbing rubble piles. They don't shatter cleanly, they crumble. And a crumbling asteroid doesn't become harmless just because it breaks. It becomes unpredictable, a cluster of boulders spreading out and still carrying the same deadly energy. So, is blowing up an asteroid a good idea? Usually no, not unless it's our absolute last option, and the asteroid is hours or days from impact. In most realistic scenarios, blowing an asteroid apart creates more risk than safety. This brings us to the world of asteroid deflection methods, the real science of pushing a dangerous object off course, long before it becomes a threat. Imagine a massive asteroid, a true planet killer similar to the one that wiped out the dinosaurs, heading toward Earth. If we discovered it today, humanity would need to act fast. But how do you stop something so enormous from colliding with our planet? Stopping a planet killer doesn't require blowing it apart. It requires precision. A tiny push today can mean a safe Earth tomorrow. Let's explore some promising ideas. Gravity tractor. Imagine a sturdy spacecraft parked just a few hundred meters from a 10-kilometer-wide asteroid, firing small thrusters to keep itself perfectly in position. No explosions. No risk of breaking the asteroid apart. Just a slow, steady gravitational nudge. Given enough time, this method can shift the asteroid's orbit by thousands of kilometers. The challenge? It requires extreme precision and very early detection, because the gravitational pull is tiny. If the asteroid is only a few years away from impact, this method is too slow. But with decades of advance warning, the gravity tractor is one of the safest and most predictable options humanity has. Laser ablation. Another futuristic method relies on the simple idea that when something heats up enough, it vents gas. In laser ablation, a powerful array of lasers heats the asteroid's surface until rock begins to vaporize. And as the hot gas shoots off in one direction, it pushes the asteroid in the opposite direction, just like a miniature rocket engine. This method has several advantages. It's highly controllable. More heat means more push. It doesn't require landing anything on the asteroid. It doesn't shatter or fragment the asteroid. But it also demands extremely powerful lasers, either stationed in space or on Earth. A clear line of sight over extended periods. A massive energy supply to keep them firing. Still, laser ablation offers a precise, contact-free way to steer an asteroid safely away. Anchored propulsion systems. For asteroids that are too large or complex for gentle methods like gravity tractors, a more hands-on approach could involve landing a spacecraft directly on the asteroid and pushing it with thrusters. This technique is called anchored propulsion, and it works by applying a steady, controlled force over time to alter the asteroid's trajectory. As massive spacecraft approaches a tumbling asteroid, which is the size of a small city, once it reaches the surface, it lands carefully, adjusting for the asteroid's low gravity and uneven terrain. From its hull, thousands of small rovers emerge, each equipped with miniature thrusters, sensors, and anchoring systems. These rovers scatter across the asteroid, climbing boulders, slipping into cracks, and securing themselves at precisely chosen spots. Once positioned, their thrusters fire in perfect coordination. Each push is tiny, almost nothing on its own, but together, thousands of them create a steady force strong enough to slowly change the asteroid's path. The beauty of this system is its precision and safety. Because the rovers are small and distributed across the asteroid, no single failure jeopardizes the mission. Over months or years, these countless small pushes add up, gently steering the asteroid away from Earth. But here's what's important to remember. Deflecting an asteroid isn't about just pushing it in any random direction. We can't simply nudge it and hope for the best. Every movement we make has to be precise, carefully calculated, and designed to protect our planet, not just today, but for centuries to come. Think about it. The asteroid we redirect will continue orbiting the sun long after we're gone. A careless push could turn one problem into another, somewhere else in the future. So every strategy, every thruster, every robotic rover has to work in harmony with the laws of physics. But what if the next asteroid we will see is very different? The one that spins faster, or with a weird shape, or concealing surprises we can't see? Could our machines act fast enough? Could we stop it in time? As we know, even the smallest asteroid can carry huge consequences. Every space rock has the potential to challenge us in ways we can't predict, testing our planning, creativity, and courage. So, the next time you look up at the night sky, remember, somewhere out there, an uninvited guest may be heading toward us. And just maybe, we will be prepared to stop it. But will we? Thank you for watching till the end. I really appreciate you being here. If you found this video interesting, feel free to drop a like. Maybe share it with someone who might find this video interesting. Until next time, take care.